Hey, thanks for joining me today. I'm really excited to be here at AWS Women in Tech Day with so many other women from around the world sharing their technical knowledge and their technical skills. This goes to show you that there are women all over the world working in tech who are doing amazing things. So what I want to talk to you about today is real-world cloud compromise. And my objective with this talk is to raise awareness about the things that could exist in your account right now that could lead to a security incident or a data breach. Alternatively, I could have called this How I'm Going to Hack Your Cloud, because that is essentially what I do for a living. Organizations will contact my company, Second Sight Lab, and hire us to do a security assessment or a penetration test to find out where they have security problems in their accounts. And if we're doing a penetration test, we will try to break in and we will try to figure out if we can get to sensitive data or credentials or get at something in their cloud environment. At the end, we'll give them a report, and the report will include all the findings as well as how to reproduce the problem and how to fix them. So I just want to set expectations up front. This is not a DEF CON talk. If you already work in cybersecurity and you are a pen tester or a security professional, you've likely heard of most of these things. So I'm not here to tell you some crazy new thing that I can do in your account. I'm going to talk about real world things that are happening right now and things that I'm really finding on penetration tests, and also a few things that are happening in the wild that are allowing attackers to get into cloud accounts. So a little bit about me. My name is Teri Radichel. I run a company called Second Sight Lab in Seattle, and I already told you one of the things that we do is security assessments and penetration tests. The other thing we do is training, and our training is a 5-day class that's geared at teams of 10 or more people who are moving to the cloud or trying to improve their cloud security knowledge. I'm on Twitter, so you can follow me. It's just my name is my handle. It's at Teri Radichel. And I'm an IANS faculty member. And one of the primary things I do for IANS is I do phone consulting. So if you have a question about cloud security and you sign up with IANS Research, you can call myself and a whole bunch of other people. I also do some research reports for them. I wrote a book called Cybersecurity for Executives in the Age of Cloud, and this is really geared at people who want to understand the fundamentals of security, but also how they apply to cloud. And at the end of the book, I talk a little bit about things I think that will change in the industry or need to change, and a little bit forward-looking. And there are a lot of these things that developers can really help with. I'm an AWS hero. There's about 140 of us around the world. We do things like run community groups, blog posts, speak at events like this. And I have a lot of certifications and some other awards if you want to go out there and check them out. This one is the GSE, which some people think are pretty hard to get. I also have a Master of Software Engineering and a Master of Security Engineering. So I try to use these two skill sets together to help teams from both sides of that equation work together in the cloud especially. So let's get started. What is the number one thing that you need to worry about in your cloud environment? You may have already heard this, but misconfigurations are a big problem. We're essentially handing people over the data. The attackers and sometimes the security researchers are just scanning the internet and looking and finding all kinds of sensitive data stored in the cloud exposed to the internet. In this quote right here, it says that there have been over 200 breaches in the past 2 years, exposing more than 30 billion records. So although this year the number of data breaches seems to be going down, presuming everyone's reporting them, the number of records being exposed is actually going up. So this is a big problem in the cloud. And don't think that just because you didn't tell someone about that thing you put out there in the cloud just for a minute, that they won't find it. They will. And this is a website that lets you search all the open S3 buckets in the world. So if you expose a bucket publicly, there are lots of people going around scanning, looking for these buckets, looking for these sensitive files, and they will add them to databases like this. There's another database which is pretty well known called Shodan, and it's a database of all the things that are exposed to the internet. So they'll have some scanners that are going all over the internet, and they'll find any host or any IoT device that's exposed to the internet and the open ports and services running on those ports. So in this example, I just searched on 3 different ports, and the first one's 389, 22, 1433, which is for SQL Server, and it will show you the number of hosts that are exposed, as well as some information about those hosts. Again, anything you expose to the internet will be discovered. Now, there is one thing about Shodan. I don't often use this on my penetration tests because for whatever reason, I don't find cloud systems in here sometimes. And I suspect that is because these scanners that this company uses are potentially blocked by the cloud provider, or else the cloud provider EC2 instances are changing frequently. And so this database is not up to date. Whatever the case, I can get this information in other ways. I don't need this database. There are so many ways I can scan and find the open ports in your network. So what am I going to do if I find an open port in your network that shows me that something's running on that port? I'm going to look for a few things. Maybe I'll try to brute force the password and get in that way if it's a service that I know something about and what the passwords might be like. The other thing I can do is go in there and look for any vulnerabilities for the software that is running on that port and see if there's something there that I can exploit. So there's a lot of cases where you can use a tool like Metasploit or some other form, or write your own vulnerability or your own exploits for these vulnerabilities and break into the host. And then once I get on the host, I can do some other things. One of the things that I can do once I get on that host is pivot. And the term pivot means I get onto the host and then I start scanning for other things in the environment that host has access to that I can't get to from the internet. And I talked about this in a talk a couple years ago at RSA with my buddy Colby Allen, who helps me run the Seattle AWS Architects and Engineers meetup in Seattle. And what we did was I came in and I showed how I was going to attack an account, and he came in and fixed the problems. And one of the things I showed was how I was able to get some Lambda credentials, and then I was able to use those credentials that could access a certain database by breaking into a web server. And that web server had access on the network to get to that database. So that's called pivoting, when you can pivot from one host to another. I didn't have direct access to the database, but by getting on the web server, I could get to it. You can watch that talk if you want to know more about it. So server-side request forgery is another way that I can access resources within your private network in the cloud, even if I don't have direct access. As you can see in this picture, I can't access the API directly, but if I can get access to the web server somehow and have the web server call the API, maybe I can get to some data that way. And this is exactly what happened in the Capital One breach. The attacker did not have direct access to call the S3 API on Amazon to get the files out of the S3 bucket that they accessed, but the attacker was able to get onto a host that had access to call that API through a role. So once the attacker could get access to that host, then they could use the permissions of that host to get to the S3 bucket. That is a server-side request forgery, or SSRF. Another problem I find frequently when I'm doing penetration tests in cloud environments is something called an open redirect. What this means is you have a redirect somewhere on your site where someone clicks a button, let's say, and they go to a certain URL, and that URL redirects them to another part of your site or another application. And what happens is, if you're not checking that redirect carefully, I can go in and change that redirect to whatever I want, and I can potentially get access to something that I shouldn't. For example, you may have heard of the AWS metadata service, and this is a service that runs on an AWS instance, and it will give you back information about that instance. So it will tell you the IP addresses, it will tell you the instance ID, and it will also tell you the credentials if you have a role assigned to that instance. Anyone who can access those credentials can use them. So what an attacker will do is find a redirect like this and essentially replace the redirect with the IP address for the instance metadata service and a URL that will bring them back the credentials, so they can get the credentials. So you have to be really careful with this one. So what Amazon said was, okay, well, create some firewall rules so that an external IP address or an external attacker cannot get access to that metadata service. So how does that work? Well, the attacker will come in on their external IP address, and the IP tables on that host, for example, will say, no, you can't access the metadata service. Only the local host can access the metadata service. So what did attackers do? They got around this with something called DNS Rebinding. This is a little bit tricky. So the attacker will use that redirect, and instead of pointing to the metadata service, which they cannot access, they will change it to point to their own website. And that website will have a domain, and the page that is requesting the redirect will have to go out and figure out what IP address is associated with that domain name. And so we'll go to a DNS server that is run by the attacker that will return an IP address for the website. All good so far. But then what happens is the attacker will download code in that redirect, and it could be to a user's browser or an application depending on how it's set up, and that code will run. And as that code runs, it will eventually once again request the attacker's website. But in this case, the DNS server will return the IP address of the metadata service, so they can get to that metadata service even though they cannot get it directly. They can get it because the IP address where that code is running is allowed to get to the metadata service. So this is another thing you have to be careful about. So how do you stop this? Well, Amazon came out with some new protections in the metadata service. You want to make sure you're running the latest version of that service. However, I have seen some things that might possibly get around that, which I'm still testing. But the main thing you want to do, going back a slide, is to make sure that you are not allowing open redirects on your web pages and on your web applications. You want to make sure that those redirects are going to hosts that you expect. Another thing I see a lot when I'm doing penetration tests is the ability to do a host header redirect. And what that means is I can change the host header, which is one of the headers in a web request, to anything I want. This may or may not be a problem. It is a problem if your website or your web application uses that host header in some way that I can manipulate. So as an example, on one site, I was able to mess around with the password reset functionality on the site. And what I did was I changed the host header redirect, and I was able to change the link in the email that came in the email to reset your password. So how would that be a problem? Well, I could tell someone, oh my goodness, you need to go change your password. Something bad happened, and they click my link in the email, which sends them to the accurate site, but I have changed the host header. They put in their email address, and it emails them a link to reset their password. That link now goes to my evil website that looks just like the legitimate website. They change their password, and then I quickly redirect them to the correct site, and they don't even know that I stole their password. So I have actually gotten that one on a website that I was penetration testing, and you can find other similar problems if the application is using the host header incorrectly. So you want to make sure you're validating that host header. So another attack is called Subdomain Hijacking, and I will demonstrate this attack through a story. There was a company that set up Zendesk, and they created what is called a CNAME in their DNS records, and the CNAME redirects to Zendesk. So let's say I want to do that for my site. I would set up zendesk.secondsitelab.com. And what would happen is when someone clicked that link, it would go over to the Zendesk service that I set up. But what happened was the company shut down Zendesk and forgot to remove the subdomain that pointed over to that service. And a security researcher, a term I use loosely here, came along and found that this problem existed, went ahead and set the service back up on Zendesk again, and contacted the company and said, hey, I found this problem, will you pay me some money? And so the company actually did pay him some money. And they also found out that he was able to see sensitive data because for whatever reason, there may have been an old link on their site, or they may have people who have bookmarks to that old page. And what they did was they were going to that old Zendesk account and submitting tickets. So the other caveat here is once the company paid the security researcher, then the security researcher figured out, oh, this company will pay me, and they came back for more and more and more. So you have to be careful with these security researchers. I highly recommend getting a pen test instead. It could end up being more cost effective. But that's basically how subdomain hijacking works. So you need to make sure that you are not leaving these subdomains open for attack. So I used to work for a company where I helped them connect their firewalls to the cloud, and I was hired to come in and help them with this move to cloud for one of their popular services. And we use AWS IoT. And so in AWS IoT, you can have devices that are connecting to the cloud service via a protocol called MQTT or something else. And when you're using AWS IoT, you need to be careful that you are protecting the inputs and outputs that are going into that protocol. There are things that attackers can do, very little things to attack network protocols. And a lot of this you are protected from, because that's Amazon's job. It's part of their responsibility. But there are a few cases where you still need to worry about this. One is with AWS IoT. You also need to worry about services like DNS, depending on what you're doing, or any services where you are controlling the protocols going back and forth, and make sure you're monitoring and that someone has not inserted something that will either exfiltrate data, or maybe they're sending commands to command and control from a command and control server to your host. So this is another thing you have to be careful about. I find a lot of issues with malicious file uploads. So what will happen is a development team will check to see that the extension of the file is what they expect. This is not enough. When I see that, I can go in and manipulate the file in so many ways, and the extension will match, but what is in the file is absolutely not right. And depending on how your application processes that file, that could cause some problems. So for example, one I found right before DEF CON this year was a company that was using a CSV file, and I was able to basically insert anything I wanted into those fields, and I showed them like there are attacks that can work on CSV files, or if someone opened an Excel, there's a whole bunch of things that could go wrong there. And it was interesting that at DEF CON, someone was actually talking about this very topic. They came up with some new mechanisms for attacking CSV files and formulas. So you have to be careful no matter what type of file you're uploading, and take precautions to make sure that those file contents are what you expect, and there are specific headers and the bytecodes that you should have in your file to make sure they're the accurate kind of file you're expecting. So I always test for these type of things, and frequently find problems. And this is related. In this particular case, what happened was I was testing a file upload form, and the website had some protections. So there were certain things I couldn't do. It wasn't perfect, but they definitely had put some thought into protecting that file upload process. And as I was testing it, I was looking at the web requests going back and forth, and I realized that they were using S3 with a time-limited URL. So I told you about my talk 2 years ago at RSA with my buddy Colby, and I talked about these time-limited URLs and some of the problems with them. So once I saw that it was using a time-limited URL, I have a certain amount of time where I can use that URL, and there's no restriction against me submitting a file multiple times. So after I submit to the file to the website and upload a valid file, I could simply re-upload anything I want. At this point, I could upload malware or malicious scripts that someone could open and trigger some sort of event on the administrative side. Who knows what, but it was definitely, those website protections weren't really helping at all. The other thing I recommend when you're doing a penetration test is give your penetration tester access to the backend where these files are processed and where they're retrieved, because depending on what you do with the file after that point, it may or may not be a problem, and you can't tell that always by looking from the outside. So it's helpful to see both sides of the equation. Of course, I'm going to go after your credentials. This is one of the main problems in the cloud, and it's always something that attackers go after and pen testers go after. And there's so many ways that I can try to get credentials. Once I get credentials, I can do a lot of bad things with them potentially. So one way is just, people expose them through GitHub, or for example, we had a recent case with Twitter where they were put into Slack and the attacker got access to Slack. So you always want to make sure you're not putting those credentials in code or posting them somewhere. And then there are web page flaws. I'm going to show you a bunch of those where I could get at the credentials. I may get access to a host via the mechanism I told you at the very beginning, where I find a service that has a vulnerability. I get on a host, and there's two things that, or something that attackers will generally do. They'll grab the password file either off of Windows or off of Linux, and they'll take it back and they'll try to crack the passwords. And there's also something on older versions of Windows, for example, where Mimikatz is used. It's a tool that can actually grab Windows credentials out of memory. So there's lots of different ways that attackers, once they get on a host, will try to steal those passwords. And same thing goes for your developer laptops. If there's some way I can do a phishing attack or some sort of other attack against developer laptops, sometimes this is out of scope, but I will often try, if I can, to get credentials that way as well. I have a story for you on that one. There was a red team, which is essentially a pen testing team. It's not exactly a pen testing team when you get into the technical definition, but people inside of a company who test the environment for security problems. And they were able to get the credentials of a person that I like to say has the special keys on AWS, who could do almost anything in the accounts. I know this person, he's super smart, he's like the most amazing person, but it's a risk for him to have so much permission. So what they did was they were able to get onto his laptop, and even though he was using MFA and even though he was using Active Directory, they were able to run a cron job and basically steal those credentials periodically and show that that was a risk for him to have that much credentials. The other thing I would try to do is social engineering, and I have a funny story for this one. I did a pen test for a friend of mine, and I happen to know that this person likes beer and he's kind of a funny guy. And so I sent a message to support, and he had given me some credentials that look like his own credentials. And I said, I'm having a hard day. I need you to buy me a beer. Would you take a look at this? So it kind of sounded like him, and they clicked the link, and I was able to show that, I got some information. So that one's kind of tough, but there are attacks right now going on where attackers are impersonating CEOs, and people are, for example, wiring money to the wrong place. So you have to really be careful with social engineering. Make sure your team is aware of that as well. I will always check authentication. There's many different ways to check authentication. One of them is just to try to guess passwords. So if I can enumerate through your users, meaning I can guess account after account till I find one that works, and then I'll try to guess passwords. That's not good to allow people to do that. And the other thing is, if you have an MFA form, don't forget to protect that form also with rate limiting or disallowing, ongoing guesses. Because if I am able to steal the username and password, and then I get to MFA form and I don't have the MFA, but I can just loop through all the numbers and there's 4 digits, I can get to that very quickly and I can get access to the website that way. Also, authorization is basically what you have permission to get to, and I find lots of problems with authorization. So some examples are the authorization is not applied across every page in the site. So there'll be some pages that simply are lacking authorization, and I can just get to them directly even though I don't have a session token or a JWT token, a cookie, whatever you're using for authorization. And the other problem is when you're using JWT tokens, you need to not just check that the token exists. You need to check that the token has not been tampered with, and you need to check that the permissions in the token are appropriate. So when people forget to do these things and all they do is check for the token alone, what happens is I can take any web request and replace one token with another. And so one user could get into another user's account, or if I'm logged in, I can get to other URLs that belong to other users and other users' data just by having a token. Even though my token should not have permission for their information, I can also potentially escalate my privileges up to an administrative user. So I will always try to do those type of attacks where I try to get more access than I should or find something that's not protected correctly on the site. Injection is the root of all software security evil. Injection means that someone will take any place on your application where they can insert data and insert bad things and try to make bad things happen. So one of the classics you may have heard of is SQL injection. And to be honest, I don't find this a lot because I think there's so many frameworks and libraries and methods for preventing SQL injection that people are doing a pretty good job with this. But there are so many other options. There's, if you're running a PHP site, I will try to insert PHP code into that site. If you are running something where I can insert commands, I will try to do some sort of command injection. There's template injection. There's so many different ways to inject bad data into any part of your website. And this includes the following. It includes headers. It includes your forms, your web forms. It includes the URLs that your site is using. It includes your HTML local storage, includes cookies. Any place that an attacker can change the data that is used by your website is potentially vulnerable to injection. Cross-site scripting is really a form of injection, but it's in its own special category here today because I find this a lot. And it's also one of the top bug bounty findings. So it's something you really want to be aware of and protect against on your website. And there are 3 different kinds of cross-site scripting. The first one is called reflected cross-site scripting. And this is the one most people are familiar with. What happens is you insert some sort of script into a page. It goes up to a web server, and the web server gives you a response that has that script in it. What can I do with that? anything that JavaScript can do. So if it's able to execute in a browser, it might steal some credit card information, it might send me user authentication information such as a cookie, or perform some unwanted action that can be triggered by JavaScript, send me a screenshot. There's so many things you can do with JavaScript. The next form of cross-site scripting is called DOM XSS, and this is a form of cross-site scripting which occurs only client-side. Now, this is a little trickier to test because typically pen testers are looking at the interactions between the web browser and the server, and they'll capture the information in between and try to figure out if they can perform some sort of attack. But in this case, the attack never goes to the web server, it only exists in the browser. So in order to test this, we have to use some sort of browser side tool or manually look for these type of flaws. And the output or the result of this is the same. I can do anything that the JavaScript will allow me to do. It's just that it's not going back to the server. And then finally we have blind XSS, also known as stored XSS. So this one's a little bit trickier, and it's also a little bit trickier to test. This one, the script gets inserted into a form, let's say, and it goes into a database and stored in the database or wherever you store that page submission. And then later someone pulls up a web page that retrieves that data from the data store and shows it on the web page. And if the site allows that to execute, then the attack occurs. And the things that can happen, it could send data back to the attacker. It could, in my case, I send a screenshot, I send cookies, I send information about the person who clicked on it. I actually created a new tool on a pen test where a customer came to me and said, we have this problem. Once again, a security researcher came to them with this type of attack and said, hey, will you pay us $500? And he did. And then what happened was the attacker came back, and the next time it was $5,000. So at this point he said, I think we need a pen test because we can find these issues all at once. And I wrote a special tool for this because I want to make sure I really found this problem he was having and found loads and loads of problems. And the tool actually will text me when I get someone clicking on a page that has a problem. So this is a tricky one to find, and it's really important because a lot of people are attacking it right now. So the next attack we have is called clickjacking, another one I find a lot. And with clickjacking, basically I can wrap your site in my own site, and I can overlay your buttons with my buttons, and I can make your buttons disabled. So that means when a person clicks on a button, it may look like your button, but it's really clicking my button, and my button can do a lot of things. So I could have someone submit a form, send some data over to my site. But again, anything JavaScript can do. And the other thing it can be useful for is when you have a cross-site scripting attack that you can't get someone to execute because you would have to basically ask a person to go add a bunch of malicious code into a form field, and who's going to do that for you? But if you can execute a clickjacking attack, then you can have that evil code inserted when they click the evil button shown here. Cross-site request forgery, or CSRF, is another type of attack that can occur. And this type of attack occurs when someone opens a tab, your website, in it, and you use cookies, and someone else comes along, or attacker comes along and gets the person to click a link that opens in a new tab. And if you don't have the proper protections, such as CSRF token that will help prevent this, then the second tab can basically execute code that will cause something malicious to happen in the first tab. So the classic example is, I'm going to transfer money out of your bank account. There are many things you can do. You can save data to forms or something. You take some action on that website that the person did not intend. Another one to look out for, especially as more and more sites are using CDNs such as CloudFront, is caching. So in some cases, you can inject malicious code into a cache. And so the person will come to look at your website, and the information will be requested from the cache, and the cache will return something malicious. One of the things to do here is go ahead and turn off that caching if you're not used to using it, first of all. Be really careful what you're caching, and understand, make sure you're not caching any sensitive data, and make sure you're not caching something that someone can use, inject bad code and somehow get that into your cache. So you're going to be really careful with that. This one is for all the people who use Google Fonts. And this doesn't only apply to Google Fonts, but I see this a lot in terms of Google Fonts, which is something that you could take and host on your own website. What happens is people make a request to Google Font to get that font to display their website, and the referrer to Google Fonts will be a URL that contains sensitive data. So you have a URL that has some sort of secret or a session ID or some other kind of sensitive data in it, and that referrer will be in the web request going over to Google Fonts. So you want to protect against that. I actually wrote a blog post about the importance of protecting your site when you're using third-party, includes third-party code. So if you want to look at that, you can check that out on my blog. Request smuggling is one that's a little bit tricky. Basically what happens here is someone's making a request to a web server, and the attacker comes in and makes the request to the web server about the same time. And as I do that, the response comes back from the API server through the web server, and it gets confused, and it ends up sending part of the response for the legitimate person along to the attacker because of that malformed request that the attacker submitted. So they're able to potentially see some sensitive data. And this is something I find somewhat frequently. And the last thing I want to talk to you about is API attacks. So I talked about API attacks at RSA this year, and I showed how I create a fuzzer for a company that wanted me to test their APIs and give me a Swagger file. And a fuzzer is a tool that I can use to quickly iterate through numerous different attacks. And because I had their Swagger file, I knew all the inputs and fields and everything about their API. I don't actually recommend only testing your API. I think you will get a limited picture and potentially miss some vulnerabilities that way, but it was an interesting project. And doing that project, I was able to get one of the requests to send me back a token, basically a JWT token. Well, that's not good. And then I was able to take that attack string, submit it again, and replace the token with some script, and it executed. So basically I had a cross-site scripting flaw at that point. If you want to watch that video, it's out there. It's from RSA this year in February. But the moral of the story here is that attackers are going after your APIs directly. They're not always going through your website. They're going straight to your API. If you have an API that doesn't need to be exposed to the internet, don't expose it to the internet if you can avoid it. If you need to expose to the internet, you have to be really careful and protect those APIs and make sure that they're not subject to any of the attacks that I just mentioned that your website will be subject to. So this was not a complete list. This was just some of the things that I see sort of frequently when I do penetration tests. It is not an extensive list. There are so many other ways that your website can be attacked, and so you've got to be really vigilant on these things. So how can you prevent all the problems that I just showed you? Clearly, I don't have time to tell you how to mitigate every single one of the things that I just showed you in great detail. But what you need to do is go out and follow the best practices, because the best practices that are written in many places will tell you things that will help you prevent these problems. First of all, AWS tells you how to secure the services that they offer. So for each service that you use, go out and look at the security controls and the best practices for that service. And do that before you start using it. And then go to the Center for Internet Security and look at the CIS benchmarks. Those will tell you how to configure things like operating systems and your Amazon cloud environment, also things like Kubernetes and Docker and many other infrastructure products. It will tell you what are the best practices for securing these things and follow those. And then take a look at the Open Web Application Security Project. Almost every single one of the web flaws that I mentioned are out there, and they'll tell you how they work and how to mitigate them. So use that as a resource as well. Think about your deployment pipeline. How do things get into your environment that you don't want to be there? They're getting in there through your deployment pipeline. So create a solid deployment pipeline. Consider using tools that will monitor and check for certain types of flaws. They won't find all the things that I showed you, but they'll find a lot of them. Also, you need to do monitoring in your accounts. So even though you're trying to prevent bad things from going in through your deployment pipeline, something's going to get in there, and you need to have alerts and monitoring that will tell you when something gets out there that shouldn't be, like an S3 bucket that's exposed publicly to the world, or any of the other myriad of services that can be inadvertently exposed publicly. You want to get an alert right away, and you want to have monitoring so you know that's happening. And of course, your security team will have monitoring as well. They'll be looking for security incidents and other problems. And then consider a cloud penetration test. So I used to be a developer for many years, and I was very concerned about security. I ran a software development company prior to my current company, and we actually had a data breach. I wrote about this on my blog. And so I was very concerned, and so concerned that I wrote something like a WAF, but the term WAF did not exist at that time, or a web application firewall, because I wanted to protect my websites. Even though I was very concerned and I knew a lot about security, I also had a full-time job being a developer. And I can tell you that as a full-time penetration tester, it takes full-time work to get out there and understand all the threats and to stay on top of them and to learn all the new threats and how to test for all these problems. So you're going to be better off if you, sooner than later, just bring a penetration tester in, let them evaluate your account and tell you, what sort of flaws exist. If they're good, they'll also tell you how to reproduce them and how to fix them. So thank you very much for listening to me today. I really hope you learned something. And I know there's some quizzes at the end with some prizes, so hopefully you'll fill those out. Also, hopefully you got a chance to ask me some questions along the way, and I hopefully will have some time to answer those. If you want to take a look at my company, it's secondsitelab.com. If you want to reach out about any of our services, you can connect with me on LinkedIn. And I have a blog at medium.com/cloud-security where I write a lot of things. I mentioned I had a couple of blog posts out there, and I mentioned some of the presentations I've done before, so you can find links to all of that and my book on my blog. And I'm always posting things on Twitter at Teri Radichel. So if you want to learn more about what I'm up to, you can go there. So thank you very much.